The question is, in the figure, a uniform rod of length L is equal to 13 meter is pulled such that P is pulled with 34 meter per second. So this point is pulled with 34 meter per seconds, and the other end of this rod is fixed at a parabolic curve of equation y is equal to x square by 20. And the angular velocity is we have to find out. So now, as we can see that at this instant, the rod has both rotational and translational motion. Yes, but we need to find the angular velocity only. So we need to think about a pure rotational motion. So we need to find such axis so that only pure rotational will be seen. So this is this problem is from the concept of instantaneous axis of rotation. Instantaneous axis of rotation. So how do we find the instantaneous axis of rotation? Let's find out. So if this is the rod, the velocity of point P is nothing but Vp is equal to 34 meter per second. And similarly, if this is the curve, right? And as the velocity will be going, the velocity will be in the direction of tangent. Say this will be Vq. And how do we find the axis, instantaneous axis of rotation is if we have the velocity at 2 points of a rigid body, then we draw the perpendicular to those velocity vectors. So we draw the normal to the velocity vectors, and we will have instantaneous axis of rotation. What's the specialty of this axis is nothing but if the rigid body have both rotational and translational motion, around this instantaneous axis of rotation, the rod will seem to have only pure rotational motion only. Okay, so basically you can say that this rod have the angular velocity omega at this instant. Now, how do we find this instantaneous axis of rotation? The points are given as point Q is given as 10 comma 5. Okay, and we need to find the intersection point. So let's find out Q also. Sorry, let's find P point. So as this P point is on the x-axis, so we can assume it as x comma 0. Okay, and the length is 13 meters. So the point P will be uh, so 13. The distance between the P and Q is 13. So 13 is equal to root over x minus 10 whole square plus 0 minus 5 whole square. So this will be 169 minus 25 is equal to x minus 10 whole square, or x minus 10 is equal to plus or minus 12. So x is equal to either it can be 22 or minus 2. But look at the figure here. So x is equal to 22 will be something in the positive x direction, but we need to find as the origin in this figure. You can say that origin is here. So obviously this will be minus 2 comma 0, the point P. So now we have the point P is minus 2 comma 0. Obviously by looking at it we can see. And the normal will be in the perpendicular direction. So the equation of this normal is nothing but x is equal to minus 2, simply directly. Okay. We need to find the normal at the point Q also. So first we need to find the slope of this particular normal which is passing through Q. So how can we find, given the given equation is y square is equal to x by 20. So, sorry, y is equal to x square by 20. So, dy by dx is equal to x by 10. And at that point, at that q point, the slope will be 1. This is the slope of tangent at q. So, the slope of normal will be slope of normal is equal to simply minus 1, perpendicular. Okay. And so we can use the straight line equation y is equal to mx plus c, y is equal to minus x plus c. As since this straight line is passing through 10 comma 5, so this will be y is equal to minus 10 plus c. It implies c is equal to. So now we have the equation y is equal to minus x plus 15. And this the we need to find the intersection of this line 1 and x is equal to minus 2. This is 2. So intersection point will be y is equal to minus of minus 2 plus 15 is equal to 17. So now we got the y is equal to 17, which is nothing but the between this is the distance between instantaneous axis of rotation and point P. Actually, this is not just distance, the perpendicular distance. Okay. We needed to find the perpendicular distance from the point P. So this is nothing but r of rotation, r of small r of rotation. So for finding omega, omega is nothing but velocity by r small r. The velocity is given as 34 meter per second by the small r is given as 17 meter. So omega will be 2 radians per